What is up, everyone? Welcome to the 6th tutorial in our Python language basics. This will be the first tutorial we'll cover on operators examples. We're just going to go over a few of them. Specifically, we're going to be covering the arithmetic and the assignment operators. I figure we'll just focus on these ones here, and then we'll cover two more sets in the next one. Again, we're not really going to go over the other category of operators I talked about. We'll kind of mix those in with the rest of the tutorials when they're really relevant. So let's head on over to Google Colab again, and we can pick up where we left off. So if you remember, the assignment operator is the simple equals operator like we see here that we've been using up until this point. I don't really see a need to cover that again, seeing as we've talked about how we can use it properly, assigning literal values like this or other variable values like this. Okay, other than that, we have our arithmetic operators. So I guess we can just jump right into those. So we know that for the most part, we perform these operations on number type variables, although we did briefly talk about how we can perform them on strings. So just a couple of quick examples using numbers here. Let's say that we wanted, or that we were keeping track of health. I think we have a % health, but now let's keep track of some actual player health. So we'll create a variable called current health perhaps, or maybe we can just call this health. Okay, and we're going to set it equal to 50, just completely arbitrarily. So here's an example of the assignment operator. Let's say now we want to add a certain amount to it. Okay, so again, we can do health equals health plus, let's say we want to add 20 to it. Okay, now this is going to do something different than if we did, let's say, new health is going to be equal to health plus 20. Okay, so these are doing very slightly things. We're still adding 20 to the current value of health, so they'll still result in 70 here, 70 here, but the difference is that we're storing 70 back in health, so that health itself is being changed. Here we're actually assigning this to a new variable, and so there's no actual change in the value there. Just to demonstrate this, let's actually do new health first. Okay, and at each step along the way, we're going to print out the value of health. Okay, and we'll go ahead and just run that. Okay, so you can see at first it's still 50, even though we added 20 to it. And the reason being, again, because we are adding 20, but we're storing the results back into a different variable. Whereas with here, we're doing this same operation, but we're storing the results back into the original variable. Okay, so this is the current value at that point in time. We're adding 20 to it, and then we're storing it back. Okay, the other operators work the same way: subtraction, multiplication, and division. I guess just in case you've never seen the modulus, floor division, or exponentiation operators, I guess we can demonstrate those. So let's say we have, for whatever reason, we have an x position equal to 5. Okay, and we need to get this divided by 2, but we need the remainder specifically. We'll also do the same with floor division. So let's just print x pos modulus 2. So this will again get the remainder of this division, and we can do the same thing for the floor division. So this returns a remainder, this performs a division and discards the remainder. So what do you think we should get? Well, for this one we should get 1, because 5 divided by 2 gives a remainder of 1. And for this one we should get 2, because 5 divided by 2 again is 2 with a remainder of 1, so we just discard the remainder. If we run that again, we should get 1 and 2 respectively. Okay. Similarly, if we did x pos to the power of 2, okay, we should get 25. Again, note how at the end of this x pos is unchanged. Okay, it should still be equal to 5, and indeed it is. Okay, so again, all of these operations are performing the actual mathematical operation, and then it's going to return a brand new result, leaving the original variable untouched unless we're kind of reassigning it like this. All right, so that's pretty good. What about with strings? I did say that we can actually add strings together. So we can do that with the plus, the addition operator. None of the others really work with this. We can't subtract strings, multiply, divide strings. Doesn't really make any sense, but we can definitely add them. So let's say we have a first name. I'm just going to do my own. Okay, and then we have a last name. So we'll do last name is equal to that name. Okay, so this is my last name, first name. And let's say I want to string these together into a full name. In fact, all I'm going to do is just print out the full name. So I'll just do first name plus last name. Okay, so I'm taking my first name and I'm adding it to last name. So what do you think I should get? Well, you can see that I get Nimish Narang, but the annoying thing is that's all one word. But that is actually to be expected, because we're taking this and we're literally just gluing it to the end of this. If I was smart about this, what I could do is leave some space here, or leave some space here, or I could do this. Okay, and that would give me, all three of those options would give me the same result, just gives me my name with a space in the middle. Okay? Now, that is just the basic arithmetic operations. What about the kind of combination arithmetic assignment that I talked about? So just to quickly recap, we're going to create a new cell, and these are going to be basically our same arithmetic operations, but with the equals on the end of them. So I'll actually just demonstrate the plus equals, and then the rest of them you should be able to kind of figure out. The usage is exactly the same. Okay, so basically using those operators, we're kind of doing something like this. We're performing the operation, and then we're storing that back into health. Okay, so let's take health, okay, and we're going to reassign it back to 50. That's fine. Now, what if I do health plus equals 20? What do you think the result should be here? Well, it should be 70, okay? And this is actually changing the value of health. So if I print out health here, now I should get 70, because essentially what this line of code is doing is this: health equals health plus 20. Okay, so it's taking whatever current value it has, and it's adding 20 to it, and then storing it back in. Okay, so taking whatever value health currently has, it's adding 20 to it, and then it's reassigning that back. So the same thing would be true if we did the minus equals. So let's say health, I guess we'll demonstrate one more. We'll do minus equals 50, for example. So we have 50, we've added 20 to it, now we're subtracting 50, so we should get 20. And indeed, we do. Okay, so again, these operations, these combination operations, will reassign a value, so it will change the original variable. But just the basic arithmetic operations leave the original variable untouched. Okay, so we can combine all of the arithmetic operators with the assignment operators. So you can do addition, subtraction, multiplication, division. You can do the remainder, floor division, as well as exponentiation. The final thing I want to mention is that we can do exactly the same thing with strings that we saw up here. So we can add strings together and reassign them here. So let's say, for example, I have a name variable, okay, and I'm just going to set this equal to my first name. But I realized later on that actually I want not just the first name, but the last name stored in there as well. So what I can do is name plus equals a space. I'll just shorten it to the space and then my last name. And then I'll go ahead and print out name, and I should get Nimish space Narang just like before. Okay, so again, exact same operation with strings as with numbers here, but just be sure that again it is going to modify the original variable. And once again, we can't really perform the other operations with strings. It just doesn't really make any sense. Okay, so it's fairly intuitive that you should be able to add strings together, but subtracting them just doesn't really make any sense. Okay, so that's pretty much all I wanted to cover in this one. This was the first two sets of operators, the assignment and the arithmetic, and of course the combination of the two. What I'd really recommend you do is you play around with these. Maybe try some examples of multiplication equals, divide equals, and then the modulus, as well as the floor division and the exponentiation until you get the hang of all of these operators. When you're ready to move on, we'll cover two more sets. Those will be our conditional and logical operators. So stay tuned for those. Thanks for watching, and we'll see you guys in the next one. What is up, everyone? Welcome to the 7th tutorial in our Python language basics. Here we're going to continue on with some examples of operators. This is part 2. We're going to focus on the comparison and logical operators. If you remember last time, we finished up with the arithmetic and assignment. Here we'll continue on with pretty much the same format, but exploring a different set of operators. So let's head on over to Google Colab now. And you'll want to get yourself started with a new cell. And let's take a look first at the comparison operators. So if you remember, these are going to be our greater than or equal to, less than or equal to, is equal, and not equal. Okay, so these should be fairly well recognized. I think in elementary school was maybe the first time we covered these, if not in middle and high school for sure. These basically just return true or false based on, well, whether the result should be true or false. Okay, this is just testing equality. So if two things are equal, it will be true. And if two things are unequal, for this one, it will be true. So this is basically saying they're not equal. Now, a couple things to note here. First is that each of these operations will always return a true or false result. Okay, so if we store that result in a variable, it will always be a Boolean. It doesn't matter if we're comparing strings, numbers, Booleans, maybe some weird combination, we will always get either true or false. Okay, the second thing to note is that the values remain unchanged. So if we're comparing two numbers, those numbers will remain unchanged completely. We just return true or false based on the comparison. Okay, so let's start with the most straightforward or the most intuitive, and these will be numerical values. So maybe we could do, let's just actually print everything because there's no need to store them in. You know what, actually, I'll show you just to demonstrate this. We'll create a variable called result, and let's set it equal to 5 greater than 2. So this is quite obviously true. 5 is definitely much greater than 2. It's more than double the size. And so if we print out result, we should get true. Also, we should print out the type of result just to see that we are indeed dealing with a Boolean value. Okay, true makes sense. Boolean makes sense. Okay, from now on, we'll just kind of print out the results. Okay, so this is again testing equality. So if we did something like 5 equals 2, okay, and then the not equals, we should get false, and we should get true for these. Okay, and that's what we get. All right, also note that I am kind of just comparing literal values, so literal numbers. You can toss in variables there if you want. For example, result is, actually that's a Boolean value, that's not going to make much sense. Health is, I think, 20 at this point in time. So if I did 5 not equal to health, that should totally work too. That is going to be true because 5 is not equal to 20. Okay, good stuff. So I don't think there's much need to go over all of these with numbers. One thing with numbers that I should point out is that we can compare floats and doubles evenly. So one thing that you should see is that if a number is, let's say, like 5.0, that is equal to just a regular 5. This is going to print out true. Okay, it does. Because 5.0 is the same as just a regular 5 without the decimal place. If this was like 5.1, obviously that's not quite the case. Now, like we can test to see if numbers are equal, we can test to see if Booleans are equal. So, for example, I could do print, actually, you know what, I'm going to put this on a new cell. Okay, I could do something like test to see if true is equal to false. I mean, obviously not the case, but just in case we wanted to compare those, that is totally fine. That's a valid comparison. Also, we can compare strings. So let's say I have a first name. Actually, I think I already created those variables, didn't I? Yeah, I have a first name and a last name. So if I wanted to compare those two, let's get rid of that, is first name equal to last name. This is going to return false. Okay, so languages like Java need a special comparison operator. It's equal to, I think it's called, to compare two string values just because they're objects, but Python, it doesn't really matter. We're actually just extracting the literal values and comparing them there. Also, strings are case sensitive. So if I did something like A is equal to A, okay, and then I did A underscore is equal to, actually, this should be lowercase. This is going to be capital A. And if I wanted to test equality between them, A equals A underscore like this. Okay. This is going to be false as well because they are the same letter, but this is capitalized. This is not. That does make a difference when it comes to strings. Now, also when it comes to strings, we can actually, weirdly enough, test to see if one string is greater than the other. So let's say I have my string A, okay, and I want to test a string B like this, and what I want to do is see if these two are equal. So is A, if A is greater than B. So is A greater than B? They're obviously not equal, we know that, but we don't necessarily know if one is greater than the other, or even if this operation is allowed. So if we run this, we get false. So we know the operation is allowed. This is something that we can do in Python. Many other languages won't allow this kind of a comparison, but Python is very flexible, so it does. And also, why is this printing false? How does this make any sense? I mean, we're really comparing string values, so how can we say one's greater than the other? Well, this is actually based on alphabetical order, and specifically the position within the alphabet. So if A is the first letter of the alphabet, it is, and B is the second, B has a higher value than A because it's at position 2 instead of position 1. Technically it's 0 based, so A is at position 0 and B is at position 1, but either way, 1 is still greater than 0. Okay, so the further along in the alphabet we are, the higher the value. Okay, so that would also make sense if we had like AA, for example, because there's just more letters here. All right, so keep that in mind that you can compare strings. The string that is lower on the alphabetical value will have a lesser value. Also, weirdly enough, we can compare booleans to, let's say, numbers. All right, so if you remember, boolean values have, can be translated into strings and numbers. True being a 1 and 0 being false. So if I did something like print is 5 greater than false, okay, well that evaluates to true. Makes sense because false is going to be 0 and 5 is greater than 0. So if we did 5 greater than true, we also get true. This gets a little bit weird because we saw that 5 can kind of be converted into true. Basically anything that's not 0 is true. But in this case, it's kind of interpreting true as being a 1. Okay, so that's why this still returns true. If, on the other hand, we did a 1 greater than true, okay, then we get false in that case, so which, again, makes sense, because 1 is interpreted as true, true is interpreted as 1. Okay, so I think that's pretty much all that we need to cover. That makes sense. We wouldn't really compare strings and numbers. I mean, they wouldn't be equal. I guess, you know what, we can toss in a couple just for comparison's sake. So we might want to test if B is equal to false, or if B is equal to, let's say, if B is greater than 5, just arbitrarily testing some string value against a Boolean value and then against numerical value. Well, actually, this one is allowed, okay, because we're testing a string against a Boolean, but this one is not allowed, okay? And as you can see exactly, this is a problem. We cannot compare strings and integers like this. For some reason, this is totally fine, but this one just is not okay. I guess probably because this is a B and you can't really compare B to a number. But if you had, let's say, a number 1 and compared them, then that would be okay. I guess it doesn't even like that either. Either way, we shouldn't really be comparing these values anyway. It just doesn't make any sense given our, given the context of numbers and strings, etc. Okay, so let's go ahead and comment that out and we can rerun the cell to make sure it's all good. All right, so next up, I actually wanted to comment that out. Next up are going to be the logical operators. So for this, I'm going to start another cell. The logical operators are going to be our AND, our OR, and our NOT. Okay, so we'll start with NOT because that's the simplest. I'm actually just going to make a comment of these. So NOT, AND, and OR. NOT is just a way to reverse a Boolean value. Okay, so if I have, for example, is game over, is going to be equal to false. Okay, for this particular example, if I wanted to reverse that and say the game is over, I could say is game over equal to not is game over. Okay, and this is simply going to reverse the value of is game over. If we print is game over, actually, you know what, we should probably use Python notation for that. So we'll paste, paste, and paste. Okay, and we get true. Okay, so the opposite of false is true, opposite of true is false, and that's exactly what the NOT operator is doing. It's just simply reversing a Boolean value. Okay, what about the AND and the OR? Well, these are a way to add additional tests to our conditionals, okay? So let's say, for example, we're trying to say the game is over if some health is less than or equal to 0 and the lives is less than or equal to 0. So we can have health is equal to 0, lives equal to 0 as well. So we're going to print health is greater than, or health is less than or equal to 0, and lives is less than or equal to 0. So essentially what this is doing is it's going to test this returns true or false, and it's going to test this returns true or false, and this overall thing will return true if both of these are true. Okay? If one of them is false, or if both of them are false, it will return false. So let's go ahead and print that. Okay, so we get true printed out. Makes sense. Health is, this is equal to true. Okay? Health is less than or equal to 0. Lives is less than or equal to 0, so true and true. And that makes true. Okay? So let's say this was 1. In this case, this returns false, because at least one of these tests failed. Okay? The opposite would be true if it was an or. So if we did something like this, or lives, only one of them has to be true for this whole thing to evaluate to true. So if we run this again, we get true. Okay? So if at least one of these is true, then this whole thing returns true. If at least one of these is false, then this whole thing returns false. Okay, so that is your basic comparison and logical operators. Now, I know these are a little bit more confusing than the previous ones, just because there are a lot of these weird rules that for some reason work, even if they shouldn't. So what I'd recommend you do is you kind of test everything out, test all the possibilities between strings, booleans, numbers, etc. Okay, and test out some of these extra logical operators as well. Once you're really comfortable with all of these operations, we can move on to the next one. We will be using various combinations of these as we go, so do make sure you're comfortable with all of the operators that we've covered up until this point. I know again there are those other operators that we mentioned in the slides. We likely won't be covering them here, but we may introduce them as needed in some of the future tutorials. Okay, otherwise, thanks for watching, and we'll see you guys in the next one.